The lab this week could be divided into three parts. Firstly, we needed to measure the charge and the discharge time of a capacitor. Then we find the capacitance of a cup of a capacitor by measuring the RC time. Finally, we built a voltage divider circuit. At the beginning, as is shown now, we linked the circuit with a 9-volt power, two switches, a 680 kilo ohm resistor, a 100 mF capacitor, a luminous diode, and a voltmeter. Firstly, we use the charging part of the whole circuit, which is shown on the screen now. We closed the switch 1 and read the view shown on the voltmeter connected to the two ends of the resistor, measuring the charge time from the beginning to the moment when the view didn't decrease anymore. The time we measured is charge time of the capacitor. We did 3 times to get the 3 measurements. Time 1 is equal to 208 seconds. Time 2 is equal to 210 seconds. Time 3 is equal to 215 seconds, and the arranged time is 211 seconds. Then we used the discharging part of the whole circuit. We closed the switch to discharge the capacitor due to the fact that the discharging time is too short to be measured. So we linked the luminous diode by measuring the time for the luminous diode to go D, which is equal to the discharge time of the capacitor. We also did 3 times to get the 3 measurements. Time 1 is equal to 11.23 seconds. Time 2 is equal to 11.78 seconds. Time 3 is equal to 11.83 seconds. And the arranged time is equal to 11.61 seconds. And here is one of the discharging processes we did that day. Secondly, we linked the RC circuit to find the capacitance of some capacitors by measuring the RC time. According to the formula, IT is equal to I0 e to the power of minus T over RC. When T is equal to RC, IT is equal to I0 over E, which is approximately equal to 0.37 I0. We try to find the time when the view of the ammeter changes from I0 to I0 over E. The time is equal to the product of RC. So C is equal to time over R. By doing the lab, we got C is equal to 92.3 μF, a little bit smaller than the real view 100 μF. Actually, I have to say that reading the view of 0.37 I0 with eyes is really difficult, which may lead to the error. Finally, we built a voltage divider circuit showing on the screen. As is well known to us, in the series circuit, the views of the current through the resistors are the same. The sum of each voltage at the ends of the resistor is equal to the total voltage, knowing that each voltage at the end of the resistor is less than the total voltage. The series circuit is a voltage divider 1.